Alrighty, here's our last part of IVT. Okay, so we want to use the intermediate value theorem to show that this function right here has a 0 in this interval right there. Okay, so we said if we want to use the intermediate value theorem, we have to show 3 things. Okay, we have to show that the function is continuous. So I'm going to say f of x is continuous over the reals. And I'm just going to put in here because it's a polynomial. Okay, so I have to give some type of proof that I know that it's continuous. Okay, we had to make sure that the endpoints weren't the same. So f of 0, let's see, that's 0 cubed plus 2 times 0 minus 1 is negative 1. And f of 1 is 1 cubed plus 2 times 1 minus 1. That's going to equal 2. Okay, my conclusion, f of 0, because this is the thing that I had to show, does not equal f of 1. Okay, third thing that I'm going to show, now on this case, I'm looking at to show that it has a 0, and we said if you want to show that it has a 0, you got to show this stuff right here. Okay, so I'm going to show on step number 3, I'm going to say since f of 0 is less than 0 or negative, and f of 1 is greater than 0, which means it's a positive, so they have opposite signs, there must be a value where f of c equals 0 on the interval. Zero. And I'm just writing it a different way. Okay. So there's my conclusion. So it changed signs between the endpoints, had to go through a 0 right there. I don't know where the 0 is. I just know that there is for sure a 0. Okay. Then the last thing we're going to do is we have a little paper that looks like this, and I think it says like page 39. It's in your papers somewhere. Let's go ahead and get that out. And we're going to look at a car and its velocity. So this kind of stuff comes up a lot in physics. And we do a lot with velocity and acceleration. Those of you guys that have had physics or are taking physics, that is going to be a big help in this class. And it's way more fun. I love physics. And we're doing all the tedious calculus work right now. But eventually, many of you, because I heard that many of you want to be engineers, you will take calculus-based physics. And that's when things get really fun. Okay, so here, they're telling me I have a car, and it's traveling on a straight track. And during this time interval, from 0 to 60 seconds, the car's velocity. Remember velocity? That's just speed, another name for speed. It has direction in it. Measured feet per second is a continuous function. Okay, so that's going to be important. So we were given that information. Okay, so we don't have to prove it. Okay, and it makes sense, right? Speed, you can't just be like, well, I guess maybe if you're learning to drive a stick shift, you can kind of bounce all over the place. but speed is going to be continuous. Okay, so the table below shows selected values of the function. Okay, so here's its velocity over time. So they want to know, must there be a time where the velocity was equal to -5? Okay, well, if it's continuous, and you know that all the velocities have to fall between -20 and +10, well, yeah, somewhere in here at some time, the velocity had to be -5 because you can't skip any speeds. If you're speeding up somewhere, you can't go from 20 to 30 in one jump. You have to go 20, 21, 22, 23, and so on. Okay, so we have to justify our answer. So I'm going to start with that the velocity is continuous. And I could say given, or I could just kind of, yeah, velocity has to be continuous. Okay, we got to look at those endpoints. Well, we know that the velocity at, do I have 35? I'm going to say the velocity at 0 is -20, and the velocity at 60 is -5. Okay, we got to make a conclusion. Velocity at 0 does not equal velocity at 60. Okay, number 3. Okay, so we also have, oh, wait a second. Oh, I see what was wrong. Do we have a change of sign here? So, oh, whoops, because I did it wrong. That is 10. There. Now we have a change of sign. I was going to say, we got a problem here. Okay, so now, by the intermediate value theorem, there is a time where v of t equals -5 is guaranteed on the interval and I'm just using the open interval right there. But since these are not my endpoints, actually there is, I'm not going to use open, I'm going to use closed, because we had those values. Since -20 is less than -5, and that is less than 0. Ta-da!